In example 2, we're asked to find the greatest possible domain for the function h of x is equal to 1 over x minus 2. So the greatest possible domain means what is the domain that contains the largest collection of values. When a function contains a fraction, quite often there are specific values that you are not allowed in the domain. In this case, we need to be careful to avoid dividing by 0. Looking at the fraction, if we've got x minus 2, if we put x as 2 in, we'd get 2 minus 2, which is 0, and we'll be dividing by 0. That means the domain can be written as x is not equal to 2. But x can be any other real number. We don't need an inequality for this question because we can put any number we want in apart from 2. In part B, it says state the range of h of x. Remember, the range is the possible output values. Remember, in part A we said x cannot equal 2 because if it did equal 2 we'd have 1 over 0, so that doesn't equal 0. And if we have any other number on the bottom, we're going to get 1 over something, which will never be 0. So the range of the function can be written as h of x is not equal to 0, with h of x being a real number. Finally, we need to sketch the graph. The information we've got here can help us to do that. Remember, x cannot be 2, so we're going to have an asymptote at 2. And the y values cannot be 0, so the graph will never cross the y-axis. And we get something that looks like this. Ensure when you sketch the graph that it doesn't touch your asymptotes, but it does get pretty close to them. Also make sure that you've labelled where any asymptotes are. At this point, I'd like to pause the video and have a go at the problem that is paired with it. Welcome back. Hope you had a go at this problem first. We need to find the greatest possible domain for the function k of x is 1 over x plus 5 plus 2. So for this fraction, we cannot put the value of x equals negative 5 because negative 5 plus 5 would give us 0 on the bottom of the fraction. Therefore, we can write x is not equal to negative 5, where x is a real number. To find the range, in a similar way to the last problem, we've got a 1 on the top of the fraction. That means that this fraction can never be equal to 0. So if this part can never be 0, then when we add 2, that means we can never get an output of 2. So the range is k of x is not equal to 2, with k of x being in the real numbers. Using this information to sketch the graph, the x values can't be negative 5, so we need an asymptote vertically at negative 5. The y values can't be 2. And the shape of the graph is similar to 1 over x. So we get a graph that has two asymptotes with a general shape of 1 over x that's been translated.